However, there is the other side to this. We're going left to right there, that's expanding. But the other thing we can do is, and sometimes we will do this, is we can go the other way. And that is take something like this and rewrite it like that. That's condensing it. This is taking one logarithm and writing it as multiple logarithms. Going the other way is taking multiple logarithms and writing it as one logarithm. That's what we want to do here next, and that's called condensing. So like I said, that one is taking multiple logarithms and writing it as one logarithm. And on the properties, it's going the opposite way we were just going. It's taking the ones on the right and going to the left. All right? So if we look at that, what if I have, first of all, log base 2, so let's condense. Log base 2 of x plus 4 to the log base 2 of 5. All right, we are going the other way, so we're thinking in the reverse direction here. Well, the first thing you want to do on condensing is if you have numbers in front of your logarithms, you want to put the numbers on the inside. Now, if we do that, what do the numbers on the outside happen to do on the inside? Well, that's property 3, isn't it? If I have a number on the outside, then I can put it on the inside, and where does it go? It comes in as a power, doesn't it? So numbers on the outside, when I'm condensing, become the powers on the inside, just the reverse of what we were doing. So yeah, I want to take numbers on the outside, move them on the inside. So this will be log base 2 of x plus log base 2 of 5 to the 4th power. With me? Okay? But I still have 2 logarithms. The goal is to get 1 logarithm. How am I going to get 1 logarithm out of these 2? Well, that's property 1, isn't it? If I have 2 logarithms that are added together, then I put them into 1 logarithm. And what do I do with the numbers there? I multiply, right? Property 1 says these 2 are added and they come together into 1 log, multiply together. So it'll be x times 5 to the 4th. Now I clean that up. 5 to the 4th is... what is 5 to the 4th? 625? And so probably the best way to write this would be 625x. It'd be okay that way, but it looks a little better just to say log base 2 of 625x. All right? So it is just working in reverse. All right, what about this one? Log condense to log base 3 of x minus 2 minus the log base 3 of x plus 2. Actually, this one's easy, isn't it? Because there's no numbers in front, so I don't have to worry with that. All I have to do is condense these into 1. So how do these come together, condensed into 1? Well, there's logarithms that are subtracted. And so those condense by putting them together how? By dividing the stuff here on the inside. So this would just be 1 logarithm log base 3 of x minus 2 over x plus 2. Just divide the 2 things on the inside. Now the common mistake here is this the same? No, that is not the same. What we're saying is we're making them 1 logarithm and the inside parts are divided. So if you put log base 3 and then put another log base 3 on the bottom, that's not the same thing. It's one logarithm with the inside stuff divided. Okay? Now one quick point here, what if I change that just a little bit and made that log base 3 of x minus 2 minus log base 4 of x plus 2? Could I combine them the same way? Why not? I can't combine these. Why not? It's the same. It's got to be the same base. The bases are different. So please make note of that. If your bases are different, unless you change the bases somehow, you won't be able to combine those. I don't think it'll happen very often, but just please note there that you can't combine those because the bases are different. These have to have the same base, both of them, either on the adding or subtracting, to be able to condense them. All right, so let's do another one. All right, let's say we have to condense the log base 4 of x plus log base 4 of x minus 1 minus log base 4 of x minus 3. So this one starts with 3 logarithms, but I want to condense them into just one logarithm. How should we go about doing that? Well, just do them one at a time or two at a time here. If I just look at these two, they are the same base, so I can condense them. They're added, so how do I condense them? Well, they condense by property 1 going this way by multiplying the inside parts, right? There'll be x times x minus 1 if I condense those. So I get something like that. Now I have 2 logarithms subtracted, and those logarithms that are subtracted combine into one logarithm by dividing the inside parts. And so this is one form of the answer. Now, one thing we could do there is go ahead and multiply out the tops, distribute the x there. So either one would be acceptable there if you want to go ahead and multiply the top out. Okay? Is that one okay? All right, this one is sort of similar, but sort of different too. Okay? Take a look at this one. So we got that one? All right, what about this one? Condense 2ln of x minus 7ln of y plus 8ln of z. What's first step on that one? First step on that one would be these numbers in front. What do I do with the numbers in front? I have numbers in front, move them inside. Where do they move on the inside? They become powers, yeah. The numbers on the outside become powers on the inside. So this will be ln of x squared. This will be ln of y to the 7. That'll be plus ln of z to the 8th. And also note here I'm doing the ln. We talked about that last time. These are all logarithms, right? Base, what's the base of these? Base e, okay. These are all logarithm base e, so I can combine them. What do you see happening? Well, if I do the first two, that's subtracting. And subtracting logarithms come together in one logarithm by dividing the inside parts. So ln of x squared minus ln of y to the 7th would be ln of x squared divided by y to the 7th, right? Then to add the ln of z to the 8th, well, 2 logarithms that are added, you combine them by multiplying the inside part. So that would be ln of x to the second over y to the seventh times z to the eighth. Be one form of the answer. Or wouldn't that be z to the eighth over 1? So I could write that ln of x squared z to the eighth over y to the seventh, because that, like I said, that z to the eighth is z to the eighth over 1, so the tops would multiply. So anyway, either one of those would be okay. Question or concern on that? Let me do one more of those just to make another quick point. All right, condense. 1/2 log a plus 2 minus 1/3 log a minus 4. Well, again, we've got the numbers outside there, so those do come in as powers, don't they? So it'd be log of a plus 2 to the 1/2 power minus log of a minus 4 to the 1/3 power. However, let's go ahead and mention, what about the 1/2 power? How else could I write that? They're probably not going to write that a plus 2 to the 1/2. They're going to write that, what does the 1/2 power mean? Square root, isn't it? So this is log of square root of a plus 2 minus log, what about the third root? 1/3 power. It's third root of a minus 4. So then we're still condensing. We need one logarithm only. Again, just to make a note here, this doesn't have a base under written, so it's understood what? Base 10, okay. But they're both base 10, common logarithm. And so the two logarithms, they're subtracted, so they would come together by dividing the insides. So that would be a good final answer there. All right? Okay. Now, there's another couple of properties. It's simplifying type properties that I need to mention here. They're usually not listed in a list of properties of logarithms, but they are important and nice simplifying properties that we might utilize along the way. First of all, and we mentioned some like it before, but if I have the log base a of a, any base, and then I'm taking the log of that very same number, what happens there? Doesn't that always simplify to be something? Doesn't that always simplify to be 1? Wouldn't that be what that would simplify to? How do I know that? Well, if I have log base a of a, let's say I'm just figuring it out. A, that's asking a, right? So what power is a? Wouldn't that be the 1 power? Okay. So that's why, yeah. It's kind of a thing you can always figure out, but log base a of a is always 1. Now, more importantly, what I want to mention here for something we'll do next, let's talk about the natural log of e. Well, the natural log of e is actually an example of this, because we're talking about log base 5 of 5 is 1. Log base 60 of 60 is 1. Isn't that the same thing? Because what's the base here of that logarithm? Isn't that base e? Isn't that log base e of e? Yeah, the ln of e is 1. And that'll be a very significant simplifying property that we use quite a bit here in just a second. Yeah, anytime you have the ln of e, that's just 1. And you can punch it in on your calculator too, but it's always going to be 1. All right, so that's a property we mentioned but had before, but All right, similarly, I guess we might say, is log base b a of a to the b power. Well, it turns out if you have that set up right there, notice again I've got base a and then I've got a here. Well, it turns out if I have that, then what essentially happens is the log base a and that a cancel out and you're just left with b. Log base a of a to the b is just b. And so if I have log base 5 of 5 to the 14th power, that's just equal to 14. So essentially the log base 5 and the 5 cancel each other out. And it actually comes out of these properties. If you think about it, you can bring the b down and log base a of a is 1, so that's where it comes from. All right? Okay. The other angle to that is this one. It is the reverse of the property we have just there before it, but the same thing works there. If I have, and notice here, this is this log base a of b is an exponent. So I have a, and this is in the exponent of that, a to the log base a of b. Turns out this very same thing happens. This a and that log base a essentially cancel out, and so the answer again is b here. So yeah, if I have log of 6 to the log base 6 of 100, what that's saying is the 6 to the log base 6, that cancels out, and you just wind up with 100. The answer is 100. And again, that comes out of basically properties of logarithms. All right, so here's a couple more. So if I have ln of e to the 50th, what happens? Well, that's base e, and that's e. So don't those cancel out by that first property down here? That's just 50, yeah. The ln and the e, same base. You got the same base logarithm as you have the base exponential expression. Yeah, those just cancel out. Okay? What if I had 10 to the log of 75? The log of 75 being the exponent. That's going to be 75, okay? And that's because, don't these have the same base? Remember, if it's log and there's no base written, that's understood to be base 10. And so, yeah, that's, again, that's going to cancel out, essentially, and that's just going to leave you 75. One last one. Now, on this one, I can't, I do have 2, and then I have in the exponent log base 2, but I can't simplify right off the bat with this one. Because why? That 3 is in the way. The 3 is in the way, and that's hindering me from canceling those out. I can't do it if there's a number in the way here. However, what can I do by property 3 of logarithms? What can I do with that 3? One thing I can do with it. I can put it in the inside as a third power. All right, so let's change that to the log base 2 of 5 to the third. Now the 2 and the log base 2 being in the exponent cancel out. And so the answer is 5 to the third, which 5 to the third is 125. Okay? So those are nice, handy